Hello, here we are with lesson 4BB. So this is a little bit of review from yesterday, finding slope. Today students will be able to compare the slope or unit rate in different situations. Students will be able to describe how to find unit rate given a table, graph, or equation. And this is important for solving real-world problems like finding how quickly the amount of water in a reservoir is changing. All right, so finding the slope from tables. Remember, slope is the same thing as rate of change. And remember, slope or rate is change in y over change in x. We've said that so many times, it should be drilled into your brain now. Slope or rate is change in y over change in x. So in number 1, we can see that in the table by looking at the different y values here. So let's look from 4 to 10. From 4 to 10, they add 6. From 1 to 3, they add 2. And so following those 2 points, we would get 6 over 2, which is 3. All right, so the slope from that table is 3. Let's check the other values. Well, this one looks like it goes down 15, but the x values at that point go down 5. And so if I were to write negative 15 over negative 5, that still comes out to be negative divided by negative is positive 3. So that still comes out to positive 3 no matter which 2 points I pick from this table. Let's check here. Negative 5 to negative 2 actually went up 3. And right here, negative 2 to negative 1 went up 1. And so that would be 3 over 1, which is just 3. From negative 2 to 1, it looks like it went up 3. From negative 1 to 0, up 1, 3 over 1 again. And here, 1 to 7 went up 6, while 0 to 2 went up 2. And so 6 over 2 is our other little ratio there, would still equal 3. So every single time I'm getting a change of 3. 3 over 1 is what they all reduce to. Now we see that on the graph. They gave us a little graph here so we could graph these points. 1, 4 is right there. 3, 10 is up here. Negative 2, negative 5 is down there. Negative 1, negative 2, 0, 1, and 2 up to 7. All right, so there's all of the points plotted on the grid. And when we connect those, because it was changing the same amount the whole time, we end up with a straight line. So it's linear. All right, let's go to number 2. Find the slope and the y-intercept. Remember, slope is rate. Change in y over change in x. Y-intercept is that initial value where x is 0. So that's probably the easiest one to see first. We can see that show up right here. We have x is 0 listed for this table. It's right there. And so our initial value, our y-intercept, if you remember, we also call that b, is negative 4. Our y-intercept is negative 4, and our slope is m, change in y over change in x. Let's see how this one changed. From negative 4 to negative 6 went down 2, so that's a negative 2 change. While x went from 0 to 4, so that was a positive 4 change. All right, a negative 2 over 4 is going to reduce to negative 1/2. All right, we can check with any of the other points. From negative 6 to negative 5 went up 1. But from 4 to 2 went down 2, and so that would still be a 1 over negative 2, which still gives us a negative 1/2. All right, so there's our slope for that table, negative 1/2 or negative 1y for every 2 x's. All right, let's go ahead and move to number 3, find the unit rate. Remember, change in y over change in x. Same thing every single time, but this time it's labeled as cost. And then right there, it's super tiny. Let's zoom in. All right, super tiny. So that's cost compared to number of candy bars. All right, so let's see what this unit rate is. From $1.50 to $3, they added $1.50. But that was when they added 2 candy bars. And so if our rate of change is 1.5 over 2, or $1.50 for every 2 candy bars, what is that per candy bar? Well, we just divide, and we get 0.75. Remember, if you need to, you can pause and check that in the calculator, but I'm telling you it's 0.75. All right, so what would that mean to this? Remember y per x. Remember y per the x. That tells me it's costing 75 cents per candy bar is the unit there for the x's. 75 cents per candy bar. All right, we can check that with any of the other values if you want. Let's look from 4 candy bars to 5 candy bars. We have the change there as adding 0.75, and the change there was adding 1. So yeah, that proves our point. For 1 candy bar, it's 75 cents. All right, let's look over to number 4, find the unit rate. Change in Y over change in X. The change in Y here from 102 to 136, how do I find that change? Well, what if I can't quite see it? Then I can always subtract to find the change, because really that's what we're doing. Change is just subtraction. So if you can't see that really fast, let's do that subtraction. 136 minus 102. Let's see what that change is. That's a 4, that's a 3, that's a nothing. And so that means they must have added 34 there. Now, you might be able to do that in your head, and that's fine, but if you couldn't, you could always subtract. Right here, the change from 3 to 4 is there adding 1. All right, so that tells me that the rate is 34 over 1. Or if we put this to words, that would be 34, what is this labeled as? Miles. Miles per, what's this labeled as? Oh, hours. Miles per hour. All right, so that would be our unit rate. So that tells me they're traveling 34 miles every hour. So if they traveled 8 hours, let's see if that works out. 34 times 8. 34 times 8, that gives me a 32. 8 times 3 is 24, plus 3 is 27. Did they go 272 miles? Yep, they sure did. And so that tells me we're correct. It was 34 miles per hour. All right, here we don't have any labels for any word problems or any situation. This is just straight find the slope. Notice when it's just straight numbers, they call it slope. If it has some labels to it, they usually call it rate. But since there's no labels here aside from x and y, we're just going to call this slope, which is change in y over change in x. So let's look at this change. All right, from 13 all the way down to negative 23. That means they went down 13 and then they went down 23 more. So they actually went down 36 steps for that. 36 over negative 2 up to 4 means they added 6. And so that would be 36 over 6, which we know reduces to 6. So this would just be 6y per x, or just a unit rate of 6. All right, let's look at the back. Again, remember, most of this is the same thing, change in y over change in x, but now number 6 has us comparing. So which situation has the larger slope? All right, let me zoom out a little bit so that you can actually see both of these at the same time. Oh, there they are. All right, so which one is larger, A or B? Which one has the greater change? So let's look at both of their changes. I'm going to write change in y over change in x down here so that I know it went to the table. So let's look at the y's. From negative 6 all the way up to 3, they must have added 9. So my change in y is 9. And from negative 2 all the way up to 1, they had to have added 3. So that's 9 over 3. Now remember, you can check that between any 2 points and it should remain constant. 9 over 3 is going to reduce down to just 3. All right, so the slope for this situation is 3 y's per x. Let's check the other situation right here on the graph. So I see a vertical change and a horizontal change. Remember, we did that yesterday. So the vertical change here, 1, 2, 3, 4. It goes up 4. Up 4 is the vertical change, so change in y over change in x. The vertical change is 4. Oh, you can't even see that. There it is. The vertical change is 4. What about the horizontal change? Remember, we saw this yesterday. So from there, the horizontal change is 1. So that would give me a 1. And so that means this is going up 4 over 1. Up 4 over 1. Up 4 over 1. Up 4 over 1. So that's our slope because that's what's constantly changing. And so the slope for this one, the slope is 4. All right, so in the table, the slope is 3. In the graph, the slope is 4. So which one has the larger slope? B. B does. Change in y over change in x. Let's check that again over here now. All right, which situation has the greater unit rate? You'll notice they called it unit rate because it actually has some labels there. Time in hours versus miles for distance. All right, but still it's change in y over change in x. All right, so in this one, from 12 to 30, they must have added 18. And again, if you can't do that in your head, if you can't see what they added, you can always subtract to the side. 30 minus 12, borrow, 10 take away 2 is 8, and then 2 take away 1 is 1, and so we get 18. Just in case you can't see what that change is, you can always subtract. But from 12 to 30 was a change of 18. Over our change in x, which is from 2 to 5, they are adding 3. And so now we have 18 over 3, which reduces to 6. So what is this? 6 what per what? Well, this one is 6 miles per hour. And I'm just going to write it in PH like they do on the freeway. 6 miles per hour for this one. Now, what about part B? Well, we want to look for where the rate is. And if you recall, the rate is what's constantly changing. We constantly change things by multiplying them by each x. And so we see the rate is right there in front of the x. And so we need to think, okay, which is larger, 6 or 31/6? So let's rewrite this 31/6. So the rate is 31/6. It is, but let's rewrite that as a mixed number. How many 6's can I take out of 31? Well, I should be able to take out 5 groups of 6. That would give me 30. I would just have 1 left over. So that tells me the rate over here is 5 1/6. Probably miles per hour, probably still the same units. 5 1/6 versus 6. Which one is bigger this time? Well, whole number 6 is going to be much bigger than 5 1/6. So there we go. That situation has the greater slope. All right, last situation. I bet you can figure this one out without me even doing it. If you can, try pausing the video right now, try it on your own, and then hit play and see if you're right. I'm gonna wait. Go ahead and pause it. I'm gonna wait. I'm waiting. Pause it. Check. Okay, wait. Pause. And now let's go through the problem. All right, so let's see if you got it right. Hopefully you tried this on your own. Here's our rate right there. The rate for this equation is easy. It's in front of x, 10/9, which is equivalent to 1 1/9. There's our rate for the equation, super fast. Now let's check the graph. Ooh, this one's a little harder to see. Let's see, I have a point at 1, 1. My next point is at 4, 4. So let's see, I'm going up 1, 2, 3, up 3 over 1, 2, 3. So let's see, that slope is going to be 3 over 3. Let's check it again. Up 1, 2, 3 over 1, 2, 3. Up 3 over 3, which is just 1. So that tells me I could go up 1, right 1, up 1, right 1, up 1 over 1, up 1 over 1, up 1 over 1, and I can go up 1 over 1. So that tells me that the slope for this graph is 1. So which one has a larger slope, the equation or the graph? 1 or 1 1/9? Obviously, it's going to be the 1 1/9. All right, so that's how we compare slopes. We have to find them first and then just look at the numbers we have. Please remember to do the exit ticket and ask if you have questions.